I'm Danielle. I'm in 11th grade from Fairfax, Virginia, and welcome back to another episode of Real-Time Science. If you remember from our last episode, we learned all about viruses, and we talked about the size of a virus. We talked about the structure of a virus and how it's not a living thing because it didn't make up those 7 characteristics of a living thing. And then we talked about how a virus, even though it's so small, is able to affect large organisms like humans and other cells. And we learned it through the lactic cycle and the lysogenic cycle. So I told you in our last episode that I love learning about viruses, and I find viruses to be so interesting. And although viruses will always have a special place in my heart, I think that antibodies and the immune system might top my love of learning for viruses. So I realized that in the last episode of Real-Time Science, I kind of left the whole episode on a bad note because it made the viruses look like the big, powerful, mean bad guys, leaving no hope for us. Kind of like how Infinity War ended with Thanos winning and leaving no hope for the rest of humanity. But at least now I got you interested for watching this episode, kind of like Endgame. So yes, viruses do have their own superpowers and they do have their own strengths, but our bodies have superpowers too, and in order to fight against these viruses. So what are we waiting for? Let's start learning. To start off, I'm going to define some key vocabulary terms so you're not confused by the science words that I'm going to use. A pathogen is anything that can cause an illness. Some examples are viruses like the coronavirus, influenza virus, and smallpox, bacteria, strep throat and E. coli, fungus, mold and athlete's foot, and protist, malaria. So what is an immune system? It's a process that organisms use to defend itself from diseases and pathogens like the coronavirus. The duty of the immune system is to defend and protect us. And when you're trying to defend something, you're not just going to have one line of defense. For example, in Harry Potter and the Sorcerer's Stone, there wasn't just one test that Harry, Ron, and Hermione had to go through to get to the Sorcerer's Stone. They had to go through multiple tests, and just like the tests that Harry, Ron, and Hermione had to go through, our immune system has multiple levels that the pathogens and viruses have to go through in order to get us sick. To help explain the line of defenses that we have in our immune system, we're going to get the help of one of my favorite defense specialists. If you've watched Home Alone, then you know the expert, Kevin McAllister. If you haven't watched Home Alone, it's an iconic movie that I recommend. But basically, Kevin is left by himself at home for several days, as his family left without him on vacation because they left in a rush. Kevin has to defend himself from robbers and thieves that are trying to break into the house. So for the purpose of this analogy, Harry and Marv, who are the thieves and bad guys in the movie, will serve as the bad guys in the immune system, like the coronavirus, bacteria, and any other bad diseases. So, in the first line of defense of the immune system are barriers to the things on the outside. So, it's your skin, boogers, and snot that are actually protecting you. And if you've ever wondered why boogers taste salty, first before I explain it, if you know that boogers are salty, that means you've eaten your boogers. Boogers are salty because they contain a special pathogen fighter, lysosome. What makes any contact with the pathogen is dangerous, killing it. In the case of Home Alone, the first line of defense is the house, and the walls on the outside are the doors, which protects everything that's in the inside. The boogers and salty lysosomes are actually protection and are like the heated door that Kevin uses so that when the bad guy touches it, he gets severely hurt. Or it's like the slippery ice on the stairs that prevents the bad guys from coming in. But sometimes the bad guys are able to come in, and the pathogens pass through your first line of defense. This happens when the pathogen enters through your nose, eyes, mouth, ears, and a cut in your skin. That's why you shouldn't pick your nose, because your hands contain a lot of bacteria and pathogens that could pass through the first line of defense when you try to get your boogers out. So the bad guys and pathogens break past the first line of defense. So we have our second line of defense ready. In Home Alone, the second line of defense would be all the traps that Kevin sets up inside his house. The inside of the house will represent the inside of our bodies. So when Kevin puts crushed glass ornaments as Marv enters the house, or when Harry and Marv both get hit with a pipe, or when Kevin sets Harry's head on fire, these are all similar to the ways that the second line of defense protects us to try to get rid of those bad pathogens. So in the second line of defense in our immune system, there are 3 ways that we are protected. There are 2 types of specialized cells, neutrophils and APCs, which are large white blood cells that eat and destroy pathogens. So here's the cell, and it surrounds the pathogens and engulfs it. Once the pathogen is in the white blood cell, the cell will be able to kill it off, which I'll explain more later. Second is the inflammatory response. So when you're injured and you have a cut, chemical signals called histamines will be released by the cell, which sends a message to cause for the clotting of blood, or like a scab, which prevents you from bleeding to death. There's also increased temperature, like a fever, and increased production of neutrophils, or white blood cells, to kill the pathogens. So the next time you have a fever, your immune system is hard at work making neutrophils, so you can be all better. The third way is through natural killer cells. Yes, that sounds pretty epic, and we have cells called killer cells. And as the name says, natural killer cells do indeed kill. The killer cells patrol the body looking for and identifying diseased cells, or cells that have been infected by coronavirus, the flu, or smallpox. It will cause the cell to go through apoptosis, which is when the cell kills itself because it's been infected, and it prevents other cells from getting infected too. So now the bad guys have breached our second line of defense, and we now have to resort to our third and final line of defense. Before I explain what happens in the third line of defense, we must go over some key vocabulary words. So first, let's go and define the word antigen. Antigens are foreign molecules or a marker to a specific pathogen. Antibodies are a protein produced in a response to a pathogen and counteracts a specific antigen. They disable pathogens by binding to them. So now that we have the key vocabulary terms defined, let's talk about what happens at the most exciting line of defense. So in the second line of defense, we talked about the special cells that eat the pathogens and engulfs it. While the pathogen is inside the APC, or the special cell, it determines what the pathogen's antigen is, or what its special marker is. Once it has the antigen, it transmits the knowledge of the antigen to a cell called the T helper cell, which then takes the information from the APC, tells the T helper cell to send out a bunch of emails or signals everywhere called hormones, which make killer T cells, which destroy any infected cell, and it also makes B cells, which store the memory of antibodies and also makes antibodies. Antibodies are important because there are millions of antibodies, and there's only one antibody that matches the antigen of a specific illness that you have. It's like a lock and a key. Only a specific shape of an antibody will be able to fit and block the pathogen's antigen, which blocks the spread of the pathogen to other cells. So your immune system needs to find the right key or antibody really fast, but it has to look through millions of antibodies. That's why you could be sick for days as your body is looking for the right key. So your B cells will be making antibodies as it can make 2,000 antibodies in 1 second. That's crazy. And it keeps trying each antibody to see if it fits the antigen. Once the B cell makes the right antibody and it fits perfectly into the antigen, the pathogen is stopped and contained inside the cell. It can no longer infect any other cells. The killer T cell then comes and kills the cell with the pathogen inside. So we've talked about the memory cell a little bit, which basically stores the information of how to make the antibody or key that fits in the lock or antigen of the pathogen. So let's say you get the same virus again. Your immune system doesn't have to make millions of keys again to see which one fits the lock. It can go to its memory box and get the right antibody to kill off the virus. So your body learns and gets faster each time that you get sick with the same pathogen. So let's say you get sick with flu A one winter, but there's many types of flu, and then next year you get sick again. This means that you got a different type of flu, like type B. But if flu A does enter your body again, it can be easily stopped as your immune system remembers the specific illness you got before and can prevent you from getting sick. Isn't it amazing how your immune system is able to learn and get faster and better at protecting you from getting sick? I think it's pretty amazing. Although our second and third line of defense are pretty awesome, let's not test its ability and make sure that no pathogens cross our first line of defense by washing our hands, wearing masks, and gloves during quarantine. Well, wasn't that exciting? We learned all about antibodies and all about the immune system and how our bodies are able to defend itself from things like viruses. Well, now that you know all about antibodies and all about immune system, I hope that you're just excited about it as I am. I can't wait for another episode of Real Time Science where we can investigate more scientific things. Until next time, I can't wait. Bye!